Hello, everyone. I'm going to talk a little bit about our journey refactoring Stripe billing and how we use DDD along the journey. So let's get started. Who am I? So I'm a software engineer at Stripe. Have been at Stripe for a while, working on APIs, our billing product specifically, and I like API design and functional programming. I've recently, or not recently, but I'm really enjoying using AI in my work, my day-to-day work, to build better software faster. And the kind of goal of this talk is to look together at the architectural journey that we went through with our Stripe billing product. So to give you a little bit of background, and I don't want to make this an ad about Stripe billing, but I do think it's quite important just to kind of talk a little bit about what it is, what it does, and what it helps with. So the kind of tagline is basically help businesses create, manage, and grow their recurring revenue. And we do everything from simple invoicing to managing simple SaaS subscriptions to usage-based billing to complex contract billing. And the way I mentioned it, or the reason I mentioned this right now is because the kind of persona that uses Stripe billing is like a very small company, maybe a one-person business just issuing invoices using a dashboard. And at the same time, we also have very large customers like Atlassian, for example, that use the exact same product to write enterprise quotes and bill for very complicated contracts. And so the kind of trick or the hard part about the hard product, but also the hard technical challenge about Stripe billing is how do we create a product that kind of suits the simple use case well and in a very simple and approachable way, but at the same time is very configurable and flexible for these large enterprise use cases. And so most integrations with us are with an API. We're an API product, but we also have a dashboard and hosted surfaces that businesses use. And so, yes, we have, for example, we have a subscriptions API, fairly simple. So you can call api.stripe.com, pass in a customer and a price, and then we would kick off a simple subscription that maybe bills someone $20 a month. So that's like the kind of Stripe billing in its simplest form, so to speak. To go a little bit over our tech stack, which is also going to be important, a lot of our code is actually written in Ruby. Which might be surprising, but we don't actually use Ruby the way you would think of Ruby when you hear it. We have our own type checker that's open source called Sorbet, and it runs over all our Ruby code. So we basically have I would say a dialect of Ruby, although it's fully compatible with Ruby, maybe a little bit more restricted in terms of some of the meta programming that you can do, but otherwise we basically have a statically typed Ruby basically with a custom package manager. You can define interfaces, you can define unit types, you can define CL classes and visibility and so forth. So it's probably closer to TypeScript maybe, but yeah, using Ruby syntax, I guess. And beyond that, we also have some code in Java and a little bit of TypeScript code for our front end. So that's roughly the tools we were working with. And then here's a little example. So it's actually kind of neat. This is Ruby code. You could run this without Sorbet and it'll work. The reason this works is actually quite interesting because in Ruby you can hook into your module when things are called. And so this sig thing is actually a stateful kind of Ruby expression that next time you define a method sort of remembers that you just called a sig thing and then overrides this method sort of with a wrapper that can do dynamic type checking, for example, if you want to do dynamic type checking. In practice, we turn that off because it's not very performant and just use this as information for the static type checker. But the neat thing is this is just valid Ruby even if you don't use the type checker. Cool. So the journey of billing, how did we kind of go along on this path? So Stripe billing started as a startup within a startup. So Stripe is a payments was a payments company, I should say. Now we're basically beyond that in many ways. So we had this very small group of engineers that were working on Stripe billing. and iterating quickly with early customers, trying to find product market fit. And I would say we approached this very like a typical startup would approach this. So we talked to a small group of customers. We asked them, hey, what do you need us to build? And we are like, okay, cool, sounds great, we'll build it. And we build it, we give it to them, they take a look, they like it or not, give us feedback, we iterate, and we kind of iterate our way that way to like a billing product, basically. And that was actually quite successful. Like we actually had a lot of startups coming on Stripe Billing, and there's two things that we noticed. One was as these startups grew, they started to outgrow Stripe Billing and move to different products, and that was kind of not great, obviously, because we wanted to grow with all these companies. And the other thing that happened is we wanted to also go win enterprise deals. And what happened there is, our first enterprise customer, I think, said, okay, cool, we will go on this journey with you. We will help you become enterprise ready. Here's a list of 20 features that you need to build for us. And then, you will be enterprise ready, and we'll have a working billing solution. Well, turns out, those 20 features were actually, I think, 200 features or something like that. And then of those 200 features, the 30 we delivered were actually, they didn't need those at all. And then the 20 we delivered, they were, kind of what they needed, but kind of not what they needed. And so, it kind of turned into this. And then the next enterprise customer came along, and the story kind of repeated itself, basically, right? And so we're like, oh, okay. We're actually not doing this. Something's not going well here. We need to actually change our approach. It's a good problem to have, but so basically, kind of reflecting on that a little bit, we were really in this like feature-focused development mode, I would say. So a lot of focus on features and not a lot of thought on like platform. So what is actually underpinning these features? What are abstractions we're building? Are we building leverage? Not a lot of thought on that. And at the same time, like if you look at the inside on at the code base that we were building, the kind of coupling and complexity of the code base got worse pretty quickly, right? And so like, you wanted to figure out what a feature did. You had to look in a lot of places. You wanted to add a feature. Well, where do we even add it? It just kind of became harder and harder to kind of work with the code base. And that made us unhappy, made our customers unhappy. And so basically the question is, well, now what, right? Now what do we do? So some example problems that I wanted to highlight that we sort of discovered looking at our code base. I think the first one is orchestration code entangled with core business logic. So basically, we do have a lot of pure calculations in a sense that should be simple functions that you can just run and test. But it turns out those are like distributed with interleave with database calls and other stuff. And so now it's like hard to test, hard to modify, and hard to reason about. Very related to that, data flow unpredictability. So any part of our system could read and write like database models. And so same problem. It's kind of just like hard to understand and follow what's actually happening and what's depending on what. We got large functions with many arguments. Procedural code, not enough abstraction. Tightly coupled modules or the lack thereof. So basically, everything is just one. Basically, everything's just one. Turns into this one big blob that gets harder and harder to move, and testing becomes a challenge too. So pretty unfortunate state, I would say. And so the question is, or what we wanted to get to, is this platform mindset. Like instead of building a product feature by feature, we actually want to build a platform, a billing platform. The idea of a platform is basically, okay, at the bottom we have kind of some reusable primitives, and then we build a clean orchestration and configuration layer on top, right? So you can think about a subscription. Maybe you decompose that into a ledger, a scheduling system, something that orchestrates payments, and so forth. So the approach would basically be, okay, let's disassemble these opinionated implementations into these pieces, and then figure out how to put them back together, and maybe also put them back together in some interesting ways. Sounds great on the slide. We even had a cool tagline: "Complete for most, configurable for all," which that's how we want our customers to feel about our product. But the question is, how do you get there? Because we have a huge, massive code base with a lot of features and a lot of customers and a lot of production traffic. So stopping the world and just starting over isn't going to be what we can do here. So we actually tried a few approaches. The first approach that we tried is what I call a top-down refactor. So basically, you have an API request coming in. The first thing you do in the API request is basically you branch, and you have your old logic and your new, your kind of clean implementation running. This had we tried this. This had a couple of big issues. One is it required a lot of staffing on this new logic branch to make meaningful progress against this old one. I say required because I think maybe in modern times with AI, this calculus might change, but that's sort of where we're at. You have to perform a data migration at some point to get from your old messy data schema to your new world. But I think the other part that really made this super hard is that everything has to be perfect before you can cut over traffic. In billing, we always say everything is an edge case, so nothing is an edge case. And a bug or a mistake on our end means that someone pays too much or too little, and that's pretty bad. So we ended up sort of abandoning this approach because it didn't really pan out for us. So the next thing we tried was, okay, well, what if we just refactor our code in place and see if we get into a good state? I mean, it seems reasonable. Everyone's refactored some code in the past, and it is sometimes manageable. I think So one positive outcome of this was we actually did uncover the correct abstractions on paper. So we actually figured out, okay, cool, here's these building blocks we need to build. Here are the clean abstractions we need to get to. But we had a lot of trouble materializing them in practice. And one of the reasons for that is that it's extremely difficult to measure progress. Are you actually getting to these abstractions, or are you just moving code around? And I think what we found is we actually were just moving code around and not getting to a good place. And so that approach also didn't really work out for us. So then comes approach number 3, which we call the middle down refactor. I'm running out of names maybe, but the idea is basically, okay, cool, we know what the abstractions are we want, so why don't we pick a part of the billing problem? Not the entire API and not a whole thing, just a part that, and what we picked basically was the kind of billing engine is what we call it. So basically the part that is responsible, given pricing information to kind of, and a service period to kind of figure out, okay, what do we need to bill this customer right now? So it's basically a pure computation that we just kind of carved out. And we'll adjust the orchestration code around that to sort of make it clear, okay, here's where this billing thing happens. We're going to put a clean interface on top of that, and then we're going to go and start refactoring that. And so it's basically much more scope than top-down, right? Because you picked a sub-problem. It's also very easy to measure progress, because what we did end up doing is we basically ran a shadow mode experiment where in production we were literally just comparing the two, the old logic and the new logic, against each other. We didn't really care how this was implemented, what it was doing under the hood. There are some challenges with side effects that you have to be a little careful about that we also learned the hard way, but it gave us these really nice dashboards where you could just see, you have a match rate. Match rate is 20%, 30%, whatever, and grows as you refactor. And also, you are starting from good abstractions, right? You're not, it's clear that part of the calculus is working. So that's sort of the approach we went with. So the method is, introduce a clean abstraction, solve the problem, rewrite the orchestration around them, and run this experiment. So sort of what I mentioned. This was nice. The first few abstractions that came out, were easy. It was easy to do. We were, patting ourselves on our back. We're like, okay, cool. We've solved this problem. We have code now that looks good. Here you go. There's a lot of other code that's not looking good yet, but we kind of figured this out. But then as we moved along, we sort of figured, oh, things are getting messy again. That's weird. Questions came up like, how do we organize our abstractions? Yeah, we identified them, but how should they relate to each other? Where in the code physically should I put them? Another question we had is, what should we even put in what abstraction? How do, as we evolve these abstractions, what are the rules around that? What are the principles? A very important question for us is we're a fairly big team right now, and there's very senior staff engineers. There's also junior engineers that just started. How do we actually govern that the code base moves in the right direction that we want from an architectural perspective? And then another thing we ran into is we had a lot of conversations on the team about abstractions, and we try to answer these questions obviously, but we were sort of not really speaking the same language always and meaning the same thing, and so we didn't really come to good conclusions always. And so that's kind of the next problem to solve. And so this is where domain-driven design comes in. So basically the idea of domain-driven design is that you sort of focus on the business domain and not the tech concerns, because that is, I think, one of the challenges we ran into frequently, where people were thinking, okay, we should put things behind clean interfaces. Let's introduce an interface, great. But what are the semantics about the thing? What does it represent in a business context? It kind of was an afterthought and not the thing we were thinking about up front. And so domain-driven design kind of, forces you to put that up in front, and it basically then gives you a language for what are all these abstractions called, how do they relate to each other, and so forth. And then you can start to organize these concepts into what domain-driven design calls bounded contexts. So you can kind of have we'll have some examples in a bit, but basically the idea is that if you're working inside one of these bounded contexts, you don't have to worry about the other bounded contexts. So you kind of, it kind of reduces the scope of a team, for example, what it needs to think and worry about. And then practically, it also has some tools around how to actually translate that into code, so that it doesn't end up just being a whiteboard exercise where you go and say, okay, cool, these are my bounded contexts, these are all my concepts, but now what? How do I actually, how does it actually help when I write the code? So, and then one last thing that I think, so the story, me and my manager were basically brainstorming how do we solve the previous problem, and he suggested, let's do domain-driven design, and he said, go read the book about it. And so I read the book about it, and I was like, this sounds kind of academic, to be honest. I don't know if this is gonna fly. And he's like, well, let's just be pragmatic about it, and we don't have to follow it to the letter, but we should be strict where it's important to be strict, but we're also totally fine with adopting it to our code base and our team. So let's be pragmatic about it. So the context map basically is, okay, let's organize billing in this example into a couple of, I would like subdomains basically that are fairly self-contained. So basically we said, okay, cool, there's a sales bounded context, and the idea is that is sort of the bounded context that is responsible for representing the relationship between a customer and a merchant. So this is where the subscription object would go, because that sort of represents you agreed to paying $10 every month, right? And this subscription object doesn't need to care about how these $10 actually get collected later, for example. And the team that's working on that doesn't need to care about it either. That's sort of happening downstream. We have a builds domain. So the builds domain basically says, okay, cool. Now that you know that you want to collect $10, maybe you want to add a discount and you want to calculate taxes on this thing. Again, something this thing doesn't need to care about, but this thing does need to care about. So that's the responsibility here. We have a servicing bounded context that sort of takes care of, okay, because you bought this, what access do you get? Do you get access to the premium, I don't know, membership or something like that? Or this is responsible for tracking usage of your thing. The product catalog is probably pretty self-explanatory. So this is where you kind of define what you're selling. And then there's this other bounded context that's very interesting, which is just other code that exists in the world that you also need to interface with and think about. And so yeah, this sort of helped put a lot of structure actually already in the way we thought about the billing problem. And now when you go into a Slack channel, which I cannot show you, but yeah, you will see people using these terms all over the place. And when we're having technical discussions, we're having discussions around like, does this go in the sales context? And then why not, and so forth. And it turns out it's actually not always easy. And coming up with this took us a long time. And it's also probably not perfect, and there's maybe some tweaks we have to make. But I think this was like probably one of the most important exercises we did trying to get into this world. So yeah, what is a bounded context? Well, as I said earlier, the white is a little bit, anyways. But the idea of the bounded context is basically you sort of have a sub-problem that you need to solve within your broader business context. In this case, I just chose servicing as an example. So servicing is sort of responsible of managing entitlements, doing usage metering, and maybe some other stuff. And the engineers that are working on this box here really don't care about the subscription thing I talked about, or builds, or anything like that. They can kind of just focus on this. So the bounded context thinking can also help with your team organization and not just your code organization. And then if you zoom in a little bit more into like one of these modules, basically you'll see that the metering module, for example, decomposes into a couple of things. So the blue boxes here are what called application services. So these are basically they're logical service, not physical services. So don't think of these as like machines that are running something. These are just like logical, organization for code, basically. And these are responsible for they do two things. One is they have a public API that you can talk to, so like an interface, I guess. And two, they're responsible for orchestration. So this is where all your orchestration logic goes. And then all of this code here is supposed to do is either store data or evaluate basically business or orchestrate business logic that you define in this yellow box I put here, which is your domain logic. So your domain logic is basically what are your core data types in this world, and what is the core business logic in this metering world. And this here is supposed to be basically pure. We had a lot of arguments about is this Haskell pure, or how pure does this need to be? But the purer you keep this, I guess, the nicer it is to test. You can write really cool unit tests on this. You can do property testing and all this stuff on this. So I think there's a lot of value in keeping this very pure, I guess. And so we actually ended up keeping it, I guess, very pure. And then you have repositories to persist data. And then you have this cool thing called anti-corruption layer, because remember the brown box that I showed you earlier, which has a bunch of code that has not been refactored yet. Well, this is a really cool tool to basically say, okay, there's this random code that I don't want to touch right now. And in the refactoring world, it's really important to do it incrementally still. You can basically define an interface over it, and then have a messy implementation that basically gets shielded off of everything inside here. And so the interface basically translates the messy world into your domain world that you can then kind of use here interchangeably. So it's a nice way to incrementally approach this. And it doesn't strictly have to be calling into messy code. Maybe you're talking to another bounded context and you want to translate it into your domain early or something like that. That's also what this can be used for. But we sort of primarily use this for talking to our legacy code. And then one more thing to note is basically as I said, the domain logic is pure, so you can never kind of call application services that orchestrate from your domain logic. But also your domain logic is entirely private to this a module here, so you can't call into it from the outside. It always has to be exposed through an application service so that someone else can use it. So yeah, I already talked about the application service. Basically, it's the orchestration layer. Other app. It talks to other app services. It is a public interface. Calls domain logic, access control, and repositories. Okay, I thought I was going really fast, but now I think I'm going slow. Okay. Anyways, so anti-corruption layer, I guess I already covered that. So we can skip that. That's good. So here's another interesting thing that I don't think DDD really prescribes, but we kind of needed that because of the way our code was written. So basically, we have this unrefactored code up here. And one thing we unfortunately do in this code is we have these database models that we pass around. And basically, the business logic runs on these database models. And they're sort of mutable. They're persisted sometimes, and sometimes not. But we want to start pulling stuff from this into this clean world. And so we basically came up with this thing that we call patch, where the kind of model kind of gets translated into something, into a clean interface. Then you do something with it, and then you kind of surface back up a patch that you can apply onto this model, so that the logic before and after can kind of remain unchanged. Yeah, and then domain types and services. So this is your pure business logic. Here's an example. Basically, the idea is that you I guess represent your domain here really well. I think one trap we fell in early, which was kind of like I would say like a leftover sort of from our old way of thinking, was anemic objects. So basically where you have a data structure that's just a bag of data, but it doesn't actually abstract anything away, right? So like in this example here, I have a draft and an open invoice, for example, and the domain actually enforces, for example, that you can't finalize an already open invoice. So basically we have this operation called finalize that goes from draft to open. And once you're open, you can't, the domain will enforce that you can't, finalize an open invoice again, for example. So you want your domain basically to encapsulate like the business rules. And what we found initially basically was that when we weren't very strict about this, we just had bags of data, and then it's very quickly that business logic leaks out of that again, because you can just inspect it and do whatever you want with it. And as I said earlier, everything here should be unit testable. So this looks great on the whiteboard. Now let's bring it to the code base. This is worked really well during the design phase. I think one thing that is worth kind of keeping in mind is, DDD is just another tool, and it does help you structure your thinking, and it does come with a lot of help on implementation. But the art of actually getting to the right abstractions is still hard, and it's still the tool won't solve that for you. You still have to figure out how to do that well. So the other question that we sort of we're asking ourselves, well, how do we know that our code that we actually write actually matches our what we've designed on the whiteboard, and how do we prevent it from drifting, sort of kind of what we had earlier as a problem? So we found this, I think it was someone's PhD project called ContextMapper. I don't know if you've heard of it before or not, but it's basically a DSL or I guess a little language that you can use to sort of actually encode your I guess the DDD context map your world, and represent it in a textual way. And so we took that and we basically built a bunch of tooling around it. So we have our own parser for it, and that's because I like writing parsers. But basically what it does is it validates that our code base actually matches what we had discussed during our sort of design sessions, right? And so after design sessions, we write this CML file and we check it into our code, and then the tooling will run and actually check that the code is following what we had discussed. And so it matches against directory structure, for example. So we have like a very strict way of organizing things. It'll check the interfaces of like the application servers and make sure that they are actually doing what you agreed to. And it also checks package dependencies, so that for example, the say the product catalog domain, which is responsible for representing what you're selling, never depends on the sales domain, which has that dependency just shouldn't exist in our business context, right? So it can help enforce these things, or enforces these things, and similarly, as I said earlier, the domain logic can never import something from the application layer, for example. And then last but not least, we also generate documentation from it. So we basically have a nice place where you can go and kind of just see, okay, what does our domain model actually look like? Another thought on this is governance. So as I said earlier, we have a pretty big team with 100 plus engineers. And so we need to, I guess, sometimes put some steers and some road bumps in the way to make sure that these design conversations actually happen. So one nice thing is about these CML files is that they go in our repo, and we have a code ownership model. And so the tech leads of each team basically own their CML files, and that way, the tech leads at least see what type of changes are made there. We try to structure all our design documents and discussions around CML changes. So basically, when you're proposing something, you always include the diff that you would do to the CML. And what we found is that as a team now, we're talking much more about why am I introducing this abstraction from a business perspective, not just from a technical, oh, I needed a clean abstraction here, that's why I did this. And then another cool thing that we didn't hack it in. We extended it in CML. Basically, one important part of our platform strategy was there's just so many ways in the world that people do billing that we wouldn't be able to kind of implement them all on our side. There's just like so many complex contracts and like weird pricing structures and so forth. And so we said, hey, billing actually needs to be scriptable. You need to be able to hook into it and change things. And so we extended CML that you can have this hook annotation basically that says, okay, this application service method is actually hookable. And we generate SDKs from that for external developers. And then there's a framework that sort of automatically delegates to these hooks if they're implemented. And it's a little bit more nuanced than that, but that's kind of the idea in principle. So we also, I guess, kind of got extensibility, not for free, but much easier than we would have otherwise, where you sort of manually have to look through and like find out, and then it's very easy to accidentally introduce orchestration in the wrong place again. And so we have like very strict enforcement where you can even extend, and we sort of get all the structure and orchestration around that for free, which is kind of cool. So the question is, did it work? It did. We actually relaunched our billing engine with new primitives last year. And there's a couple of things that came out of that. So one is our existing subscriptions product was basically relaunched with a bunch of new features that we were struggling to release before this. And we also launched a net new usage-based billing product that is sort of another subscription-like API, but under the hood reuses all the primitives we've abstracted. And so we could basically build basically a completely new business line much faster than starting from scratch by just kind of using all these concepts that we had extracted. And then we got this extensibility that I mentioned for free. So some learnings from this journey. One is middle down refactors work. Kind of, as I said earlier, this match rate is really cool to kind of measure your progress. So we had these I guess progress measure circles, whatever you call them, that kind of showed us where we were at. And we built a bunch of tooling to inspect mismatches and things like that. Other learning is that it's actually not that easy to find the middle. Like if you go too low, then you're probably back into not introducing the leveraged abstractions early. If you go too high, you will end up with this problem that you have to rewrite too much at once, and so you're stuck. Avoiding the data migration, I think, was pretty critical for us. And one other thing that's nice is the cutover was quite easy with this too. Basically, once the match rate was good, we knew we could just safely cut over, and we're in a good place. DDD helps, but not a solve all. So I kind of already said that. It helped with proactive design converse. It kind of drives people to a pit of success. So you kind of know now where at least you have a starting point where you want to put your code. We got some feedback. Your code base is very clean, easy to navigate. So that was great. But as I said earlier, finding the right domain modeling is still the art and the hard part. That just doesn't go away with this. It's literally just a tool to help you. And even with all the stuff we did, it's still very easy to fall back into legacy patterns, like into the old way of doing things. So this need for tooling and culture, I think, is really, really important. I think if we hadn't done our like CML and checking stuff, I think we would have probably failed. And I think even now it still doesn't check everything, and the unchecked things are the ones that obviously very quickly kind of grow in directions you don't want them to grow into. And this might be obvious, but I think I don't know if it's like it was like super obvious to me at least, which is it actually does require pretty deep domain knowledge to do this well. Like you either need to find some experts that can sort of really kind of help you understand the domain that you're trying to write software for, or you have to do that yourself. So for me personally, like I've been working on billing 8-ish years or something like that now. And I think some of these abstractions only became like very apparent to me, I don't know, after like maybe 4 or 5 years or something like that. I don't think, I think I had to just be very immersed with like all these use cases and how people were trying to approach, what people were trying to do. On the legacy, falling back to legacy patterns, I think there's like very often in these conversations when you're trying to do something, it's very easy to kind of try to like special case something where you're like, this abstraction doesn't quite work, but well, we can just do this little thing here and it'll be fine. And kind of like pushing yourself to not kind of do that and actually trying to reframe what you're trying to do in terms of the abstractions. And if the abstractions aren't right, we should change the abstractions. And then, I already said this a few times, but kind of thinking from a business product perspective first versus from a tech first perspective, it's just like also a trap that, myself and a lot of engineers fall in very quickly, where you just want to solve it with the switches you have versus like taking a step back and like, again, thinking about domain and abstractions first. Okay. One last learning, our customers benefit. This was actually also really cool. We actually took our large customers along on this journey. So we actually didn't kind of secretly just do the rewrite. We actually told our customers, hey, we need to work on our code base. Are you willing to kind of come along with this and give us some feedback along the way? And we kind of talked to them how this will impact their feature requests, where in the short term maybe it would be a little bit slower, but in the long term, here are the benefits. And it was actually really great. We got a lot of feedback and support on this. And at the end, the customers basically got extensibility, much faster releases, and also a simpler public API out of this, because a lot of times when your code internally is kind of a mess and hard to understand, how are you going to build a clean public API for that? Like, it's not really a thing. And so the customers actually benefited quite a lot from this journey as well. Okay, almost done. Then came AI. So this was actually kind of interesting, because when we were starting on this, like AI was of course a thing, but I don't think the coding, the LLMs were good enough that you could just like have them do things end to end. But Stripe has kind of embraced AI early. And one other thing we had going for us was our development is entirely remote on what we call dev boxes. So no one develops on their computer. Everyone develops in the cloud. And so what we found pretty quickly is that agent needs structure and clear instructions. So we came up with this term, human architected and agent implemented. And we just introduced a language, CML, that actually is really nice to kind of talk about code structure in a very like precise and structured way. And so we basically have this process now, right, where like, okay, first step is brainstorm the product spec. Very nice. We have a very nice integration with a lot of our internal systems, where the agent can pull from documentation, where the agent can read code and so forth. So basically, we brainstorm with the agent and a human in the loop, and basically like, okay, what are we actually trying to build? And then we get a spec out of that. Then we can go work on, okay, how do we turn the spec into a CML definition, right? And maybe a public API definition, same kind of idea. Then we can have the agent derive an implementation plan for that. And then, again, it's an iterative process and so forth. And at the end, you basically end up potentially with a very long implementation plan that, results in multiple pull requests and multiple changes over time and so forth. But then you can just feed that plan to the agent basically and just let it write the code. And it works surprisingly well. Like basically, if you rigorously go through these steps, then you actually get good code results at this point, which is kind of shocking, but also like really awesome. And then you do spend some time on code review, right? So you don't just merge this. You basically take this You review it and you maybe give the agent some more feedback, or maybe you do some manual edits at the end. But you can actually kind of ship some big features with like a like, I guess, human architected agent implemented pipeline, which is really, really awesome. So does it work? Yes. Like we've have like multiple agents that produce basically entire PR stacks. They work for hours overnight, for example, and the code runs in production. It was a cool side effect of this kind of domain-driven design CML logic, where we happen to be at the right place at the right time, if you want. Yeah, I think last slide. So looking forward, the code review problem, I think now we produce a lot more code more quickly. I think the CML files help, and focus the conversation on interfaces, but you still need to look at the code. And there are some things we've kind of been experimenting with, but we haven't, really, done anything. But basically, one question is like, should we extend CML even more to kind of, maybe represent some invariance there or something like that, so that we can have more automated checks on top of, is the agent output actually exactly what we want? Cool, that's it. Thank you for listening, and happy to answer any questions.
What was the organizational overhead cost to arrive to consensus to this domain model?
Yeah, that's a great question. So basically, what we basically organize. We basically try to. So basically, step one was get to the context map that I showed, right? And there we basically got all the tech leads and all the product leads in a room, and that took some time to figure it out. But then once we sort of had identified this context map, we basically had like pretty clear owners of like, okay, this is the tech lead and the product lead for the product catalog bounded context. You guys are the decision makers of how this stuff is modeled, right? And so I think that then helps with a lot of decision making, where there's like actually a lot less coordination, because in theory at least the other bounded context should care a lot less of what decisions you basically make in your bounded context.
How long did it take to arrive to this?
I think we probably spent like a month on it as a team, I would say, like on the context map. Like it was a hard, lengthy process, but and then we intentionally also try to take everyone along on that journey, right? Like I think we could have done it more top down, where like, I don't know, product lead, my manager, and I got in a room and just figured it out. But we intentionally didn't do that because we wanted to make sure that everyone was invested, and also like part of actually making this good and internalizing sort of what the purpose of all these contexts were. I think you were next.
Okay. First question is a Rails application. You're using Ruby, and a lot of your code is Ruby, probably running with Rails. If this is so, did you find some kind of friction trying to create context boundary using active record, because this is not the most natural
right.
Rails stuff?
That's right. Yeah, we don't use Rails.
Okay.
We do have something like active record, and we basically abstract that away from the DDD code entirely by using the repository pattern. So basically, you define your domain model, you write a repository for the like side effectful reads and writes you want, and then you have an implementation that messes with our, I guess, active record equivalent, but that never kind of leaks out of that ever, basically. Yeah.
Did you stay with the replacements you made in your code? Did you stay in your tech stack? Because I can imagine you said you replaced like Ruby code. If you replace it with Ruby code, it's easier to have this moving alongside the code base than rather if you switch programming language environments, whatever, that will increase the orchestrator cost. So did you stay within your tech stack, or did you also do refinements over language barriers?
We did both. We both moved some stuff to Java, which is a whole other interesting story. But we tried to, or we decided not to like lean too much into like trying to rewrite in a different language, just because we want to keep it incremental and make it that you can reuse stuff, and so we stayed with Ruby. And now we actually have the optionality to pull more stuff out, which I think we're going to do. But I think for now it was the right call to kind of stay in tech stack. Yeah.
Unfortunately, we are out of time for now, but you can take it on the hallway track and ask questions later.
Sounds good.
So, thanks again, Alex, for talking.